So welcome back children. Now I am going to teach the same topic, that is latent heat, through your NCERT book. So come to page number 7 of your NCERT. Now children, see, there is a line saying that on increasing the temperature of solids, the kinetic energy of the particle will also increase. Of course, yes, if we increase the temperature, if we heat a solid, what will happen? The kinetic energy of the particles will increase. And if the kinetic energy of the particles are increased, what will happen? The particles will start vibrating, because why are they vibrating? Why are they not moving? They are vibrating because solids don't have extra space. So what will happen? The particles don't have any space to move, so they are fixed in a particular place, but they have started vibrations. And as the temperature rises, as the kinetic energy rises, the vibrations also will be very high, or they will vibrate very energetically. Now because of these vibrations, the bond, the molecular force of attraction, or the bond between the particles, will start breaking. And because the bonds are breaking, the particles will leave their fixed positions. And if the particles are leaving their fixed positions, then it is not a solid, because we all know that the particles of solid do not leave their positions. So if the particles are leaving the fixed position, that means the solid has been changed into liquid, or it is getting converted into liquid state. So the point of temperature at which a solid will melt and become a liquid, that point is called melting point. So children, today's first question is define melting point. Write down here a question, define melting point, and this is your answer. The highlighted lines are the answer. Now let's move on. Let's move on to the next point. You see children, the melting point of ice is 273.15 Kelvin. Now the melting point of ice in centigrade is 0, but in Kelvin it is 273. So all of you write down second question, what is the melting point of ice? This is your question, and the answer is, the melting point of ice is 273.15 Kelvin, or 0 degree centigrade. Add this line point also. Again I am repeating, the melting point of ice is 273.15 Kelvin or 0 degree centigrade. Okay. Next, the process of melting, that is change of solid state into liquid state, is known as fusion. So the process when a solid changes into a liquid, this process is known as fusion. So your question number 3 is define fusion, and the highlighted lines are the answer. So what is fusion? The conversion of solid into liquid state is known as fusion. Next question is already given in your book. When a solid melts, its temperature remains same. So where does the heat energy go? So I have taught you in the video also. Again I am repeating. Let me show you this figure to explain you. I had taken the ice in the beaker, and the thermometer was taking the reading. So when I started, before heating, the temperature was 0 degree centigrade. But even after 4 to 5 minutes, when the ice already had started melting, I saw that the temperature was still 0 degree centigrade. So my question is, where is the heat going? I can see the heat, I can see the burner burning, but the thermometer is not showing me the reading. So where is this heat going? So the answer to this question is, the heat is being used up by the particles of solid to break the intermolecular force of attraction and to change the solid state into liquid state. So this heat has been used up, and this heat is because this heat is not being seen. So it is hidden and also known as latent heat. So children, this is your next question, and the answer to this question is, You must have observed during the experiment of melting that temperature of the system does not change after the melting point is reached till all the ice melts. This happens even though we continue to heat the beaker, that is, we continue to supply the heat. This heat gets up in changing the state by overcoming the force of attraction between the particles. As this heat energy is absorbed by ice without showing any rise in temperature, it is considered that it gets hidden into the contents of the beaker and is known as latent heat. Till here you have to write down the answer for the question I just gave you. Okay? The question is already given in your book and the answer is this whole paragraph till the line I have highlighted. Please mark these in your NCERT book. Next children, the word latent heat means hidden. Latent means hidden. Why are we calling it as hidden? Because this heat is not being shown by the thermometer. It is hidden. That is why we call it as hidden heat or latent heat. So children, your next question is what define latent heat of fusion. Your next question is define latent heat of fusion. So this is your answer. The amount of heat energy that is required to change 1 kg of solid into liquid at atmospheric pressure at its melting point is known as latent heat of fusion. This is your answer. Question is define latent heat of fusion. And the answer is the amount of heat required to change 1 kg of solid into liquid, because we all know that fusion means changing of solid into liquid. So when solid is getting changed into liquid, some amount of heat energy will be used up, and that heat energy which is used up for changing solid into liquid, that heat is known as latent heat of fusion, because this heat is not being captured by the thermometer, but it is present there, it is still there, and because it is there, it is hidden, and hence it is known as latent heat of fusion. Okay. Children, particles in water at 0 degree centigrade have more energy as compared to particles in ice at the same temperature. Now this point is very important now, and I have also explained it to you in the first video when I gave you the example of student A and B, that both the students were having the water, one was having ice in the bottle which was 0 degree, and the student B was having chilled water which was again 0 degree. Both of the temperatures of the bottle was 0 degree, but student A was carrying ice, that is water in the solid form, and student B was carrying the same water in the liquid form. So whose temperature is higher? Because thermometer reading is same. Thermometer is telling that both the bottles are having same temperature, that is 0 degree centigrade, but still there is some difference in the temperature. Tabhi to one is at solid state and the other one is at liquid state. So just seeing the states, we can say that yes, the temperature of student B's bottle is higher because the state is water and its original temperature is 0 plus some hidden heat which is not shown by the thermometer, but it is present. So whose bottle is having a higher temperature comparatively? Student B, and student B's bottle is having 0 degree plus some hidden heat which is present but not shown by the thermometer, and student A's bottle is having only 0 degree because it is solid. That solid has not yet melted.